Okay. Do you hear me okay? Thank you. Whoa, a crowd that actually responds. That's new. You know, with the whole pandemic being, you're never really seen the crowd. So nice to see big audience. Anyway, we're going to be talking about building Docker images. More importantly, we're going to talk about building minimal, flexible, and reproducible. Before we actually dive into the topic, just by show of hands, who built a Docker image in the last month? Yeah, most of us. Who built it in the last week? Okay. Who built it today? You shouldn't be doing work. But awesome. No, so we are building it. Good question. But yes, we're building it all the time. That's the whole point. And this is not the last images that you built. They're coming tomorrow. You're probably not building it, as we just heard. It's probably the CI is doing it, if you did your job correctly. But are we building can we do it better? Before we dive into that topic, we'll look why do we want to build our images that are smaller, or why do we want to build them in a more flexible way? Why are those reasons? Most likely you'll have to answer this to your boss, if nothing else. So why? One of them can be, we just want faster deployments. I know I've been in jobs where deployment takes days, hours. We'd like to get this down. You know, we want everything to be immediate. We're just in the, this is just it's a good experience, right? So nobody can object that. We also want our CI to actually just run faster. This is, in the worst cases, because we are impatient. Or if you ask your company, because you know your time means money, you're saving time and money. Then there is just less things to go wrong. It's an obvious one. Just until you say it, it doesn't. We sort of forget it. If your image is smaller, there are less things to be exploited. Yeah, and less things to go just wrong when in production, right? And there is just less moving parts. This kind of comes in the life cycle of your Docker image. When you are updating, there will be just less things updating. Generally, when you step back in the whole year, there will be, your product is just going to be more stable. More stable, happy clients, let's say more money, right? And then there are just, I don't know, building one image, 10 images, it's not really that different, right? Sometimes you want the personal challenge. Sometimes you just want to see, do I still have it in me? Can I, our jobs at some point become really repetitive, especially building Docker images. And sometimes you just want a challenge. Can I build it smaller than me 3 years ago? Well, you have to brag in the office that my image is smaller than yours. Sadly, but that is also true. I like to divide this in 3 topics, because you can see I put them. First one, it's obvious. It's time and money. Who can argue with that? We all want to save there. There is, of course, always how minimal, how much flexibility you need. You don't always want the most minimal, because then that also takes time to construct and maintain. But there is this fine line where you save money, but you also and save time. Same thing here. You have there is the other category, security or stability. I kind of group them together. Probably they shouldn't be, but 3 is a nice number. So security portion of it. Some companies in the beginning might not see this as as an important topic. The bigger you grow, the sooner you realize that this is actually most of the time you'll be spending on. And well, we are just primates. We like to compete. There are these things that we do, we like to see ourselves engineers as reasonable people. We are still humans, and that's how we take we inherit, if you want me to say this, it's from the good things and the bad things. So we are competitive, which is a good thing in some cases, not bad in some other. So, and we just like to discover things. So, yeah, we are still the caveman, cavewoman that we were so and so many years ago. So we know why we're doing it. Does anybody have any other item that, why are you building the Docker images that I missed? Because, you know, this is like, this is a list of why I was building smaller images. Any other? Because they pay for it. Awesome. Well, this kind of goes into the category of money, right? Because it's trendy. We are monkeys. We competed between each other. Awesome. So let's say this is a complete set of categories. So how do we do it today, right? In order to explain you the journey, let's see how we do it today. What better place to look is on Docker website. Not because it's the most exhaustive, but it's most likely, it's like a common place where we will all look at. And actually the list is pretty reasonable. But first, how do we build Docker images? We write a Dockerfile. We run Docker build, most likely in a CI. And then Docker image comes out and we run it. So in this example, we have a really simple example. Yeah, this is how I start also my images. Like, they look really simple in the beginning. And then you have to consider a few things, right? If you want to make them minimal, you want to use this thing called multi-stage builds, where you build on the first part, or maybe you have two builder parts, and then at the end you copy all the artifacts with things only needed to in the production, sort of runtime dependencies, right? Awesome, makes sense, right? Then you see the line where we copy all the sources in. Well, it's really important how you write your Docker file, because the layers in your Docker file will be invalidated based on your order. So if you copy something, if your Docker image depends on everything in your repository, you're going to be just rebuilding it. Rebuilding means money. We want to avoid that. So that's why I write exclusive Docker files, extensive Docker ignore files, so that you ignore things that don't trigger a rebuild. Then create ephemeral containers. Well, we try to. What does that mean? Ephemeral, it's a hard word. I practice it to pronounce it. So we are trying to build images that we can kill, remove, deploy, swap. So there is no state requiring us to bring them up again, except, let's say, a connection to the database. So these kind of images that you can swap easily. Not always possible, but we strive towards that. We want to decouple our applications. You might build one Docker image, but then sort of when you run it, or you build multiple images, but then we like to see it as, let's say, complex applications. Each process will have its own Docker image, or will be in its own container. So we try to decouple that. And you want to leverage the build cache, just the layer cache and the build cache. Build cache in the sense that the rebuilds will be less expensive, which means faster CI, faster turnaround. And also the layer when you're deploying image, so the layers will be also reused later on. There are probably a few other things, but I would say these are the main things. And you can quite quickly shoot yourself in the foot. I think that's the expression, right? Where you ignore a bit too much, the Docker image is not going to be rebuilt. You decouple your application and you forgot to include some runtime dependencies. Well, you're going to know when you're trying to run it, hopefully not in production. The build cache, you need to be smart and know what those commands that you're running are doing in the background, because they will get invalidated all the time, right? So if the command, let's say at the top, changes, all the other commands below it, or let's say statements in the Dockerfile, will be rerun. So that's just how Dockerfile works. It's very sequential, right? Yeah, but in reality, your Dockerfile looks a bit different. This is just like a small Dockerfile, at least from my experience. Most likely, you will not use the Dockerfile. You will not base your build on a Dockerfile, on a Docker image you want, because there is a SecOps team that will come to you and say, these are the rules, depend on us, and for good reasons, right? So you might have to obey those rules. When you build at scale, you need to label your stuff, because when you have thousands of images laying around and building in all the time, you need to be able to search and retire, delete stuff. Then you have this thing which it's like, should we do apt-get update or not? Do we want the latest or not? When do we do it? You tell me. It's basically from, then we also have a cleanup stages always. So we run a command and we need to know what that command did in the background to clean the cache. I think even Ubuntu images now, they do cleanup themselves, but still not all images are working. Not all tools are aware and are configured that way, especially in the Docker containers. So you need to be aware of all these little pieces. You need to set up all the source stuff, then you run your local build tool. You try to cache stuff in between calls, and then this is just a command. So nothing special, but if you compare it from the previous slide, it's already much more complicated. Just adds the complexity. And I haven't even touched Kubernetes and scaling, and it just gets, if I say worse, I mean worse in the terms of you need to know much more stuff and you can make more mistakes. So you can still consider this easy, although there are many places where, yeah. So can we do better? That's why this talk is about. So it's like a rhetorical question. I think we do. Yeah, now is this really weird because I need to shift the whole talk. So the solution I use personally is a tool called Nix. It takes a bit different approach. And just, again, I'm going to ask you to stretch a bit. Who heard of Nix? Just heard so far. Okay. Who out of those just used it? Okay. So it's like, let's say 10 people and 5 of them used it. So Nix, I think then we need to explain what Nix is. Nix is, on the website, it will say it's a package manager. But you can also consider it as a build tool. It has certain properties of a build tool. Maybe the most accurate description would be a build framework. So you can use parts of it. You can use it in different ways, right? We'll come to that. Nix is just like, how do you use it? You write a file in a language called Nix expression language, which is just basically JSON with functions. We'll see it later. Nothing to be scared about, because we all know JSON. There's also comments. So So that's the next part, and you can use it alongside your existing package manager, right? It will not break. You can still use your own tools, and it works on Linux, Macs, and, well, Docker as well. Then I mentioned before these expressions. So these are, with this expression language, you write recipes how to build packages, right? Just like in any other package manager. Those expressions we put in a Nix packages repository, where we build them and provide binaries. Meaning, when Nix does the build or installation, it first checks whether the binary exists, replaces it, or if not, builds it from the source. So it has this transparent source binary model, right? So if you use the upstream version, you most likely will have the binaries. If not, if you apply a few patches, you will build it from the source, and then you can actually create a cache in your own company as well. So you can have multiple binary caches. And on the end, if you really want to go down this rabbit hole, once you have a build tool, a builder, and all of this, there is NixOS. It's a Linux distribution. We won't be spending any time, but it's a cool thing. You can see how deep the rabbit hole goes when you're there. Yeah. And why I'm talking about this is because there is one reason why I think you should use Nix. So this is a graph, horrible, but that's the best thing I could do. This graph is taken from Repology, I think a month ago. But it's on the x-axis. There is a number of packages in package repositories, not only in Nix. So I don't know, Ubuntu, so on, Debian. And then on the y-axis, you have the freshness of those packages. So how up to date are they? So it's really important that you want to be in the top right corner, right? So the most that you have a repository with the most amount of packages, but still to be the freshest. These things here are where Nix packages fall. And most of you don't even know about it. So the community, you must assume, is not as big as any other distribution. How can a small group of people, you can ask yourself, how can a small group of people maintain a better package collection than any other distribution? We have a bit different model. Yes. As well, and also binary distribution. So this is just, so I'll explain again. The number of packages is on the x-axis. So how many packages is in this repository? Source or no source, okay? On the y-axis, the vertical one, we have the freshness. How up Okay, you hear me okay? Awesome. So my battery died. So yeah, so what I'm trying to say is ask yourself that you didn't hear of a package manager, and now this package manager does more with less amount of community members. The reasons for that is just, I would really like to explain how things work. We don't have the time, but how things, let's have an open space about this, no problem. But how things are, the basic ideas, building blocks, how Nix works, allow us to automate, sorry for the word, but we can automate the shit out of things, and we do, right? So that's why I actually, also, the level of engagement with of the community. We are for the 5 years straight, top 10, top 5 on the GitHub, which maybe also come as a surprise. You can contribute to Nix packages just with opening a pull request. So it's like the contribution process has a really low barrier, and then the PR process kind of guides you. And I hope we are all accustomed to open pull requests. Either this is just a version bump, right, or adding a new package. So yeah, there is a small amount of people do a lot of things, and well, they have all the bots and all the automation tools. So that we had the AI before the AI. So that's why I call, if you consider using Nix, that's actually the reason. Yes, Nix has certain properties, like reproducibility being one of them. It works a bit cross-platform, so you can share your packages from one system to another, inside Docker, outside Docker. But the reason, if you would ask me to choose one thing, it's Nix packages. It's an amazing collection of all the software out there. And most likely you'll find it, and if not, it's a PR way to add them. So now demo time. I prepared 2 demos. One is a bit, let's say, beginner, simple, which I think most of you will understand. The other thing, we will then take it a notch and look at more advanced things, but I'll take it slow, I promise. There's going to be some Nix code, but I'm going to take you step by step. First demo. This is how you would use a multi-stage approach and use Nix to build a Docker image. And let's see what we do, what we're actually doing here. We're using the Nix Docker image as our builder. This thing, we have some experimental features that we want to use, just that the command line below works. Nothing to it. This we configured. Then we use this command line called Nix profile install. And then we list all the packages that we want to install. There's also a website where you can search, or you can search it from a command line. And we list all the packages. And we install them. They will be installed on the system. And then a symlink to that profile will be created here in this location. OK? Easy, right? Like any other package manager, right? Then comes a bit of the fancy stuff. Then the next part. Then we take a closure of our profile. I'll explain what a closure is in a second. And we copy it to a new location. What is a closure? Closure is your profile, so what you install in that profile, and all of the dependencies, all the way, runtime dependencies, all the way down if you depend on, I don't know, kernels, GCC, whatever it is. But if this is a runtime, right? So there is a Nix store command, which is like, there is a typo, but there is the store command, which kind of creates the closure, and then we just copy it over. That's also understood. It's sort of like bundling all your runtime dependencies. And then comes what you're used to do. Now we don't use it, because we have all the dependencies, runtime dependencies, we don't have to build upon any other image. Hence, we can use it from scratch. So no layers to build from. Then we copy it. There are 2 things that we copy from, and then we just, in this case, we set a command. What did we just do? We still use the Dockerfile, but we use a multi-state approach to build a profile with all our packages that we need. And this means you can also, list, try out new things. You have access to this big collection of packages, and then in the end, it will create an image from scratch without the need to build on some other image. That's cool, right? So that's a capability that we called complete dependencies in Nix, which meaning Nix gives you the ability to think. It gives you the graph of all the dependencies. In this case, we're using this graph to say, give me all the graph and just start, and copy it over to the next image, and everything will just work. Any questions so far? Yes, yes. So we end up, thank you, we end up with the Docker image that contains everything that we want to install and their runtime dependencies, the full closure. That's the magic. And only that, nothing else. Please, another question. Exactly. I can totally agree. All I'm saying is you get access to this huge collection of packages. Let's put it differently. You could actually use any other tool from there. Maybe your use cases, maybe I have a strange use cases, but a lot of times I cannot use certain versions of, let's say, Dnode, Dino, so the Node.js Next. It's not really distributed, so what you can do is actually install it this way on your existing Ubuntu, like you have your own Docker image, which already works, but then you just need a dependency here and there, which is a bit either too new or really old. This kind of allows you to kind of bypass. This is that flexibility. Just generally, my first usage of Nix was on a really, that was 10 years ago. I used a really old Red Hat, had to SSH, and what was this trace version was really old, and I would use some new features, and I used Nix to bring up new trace and then clean up the whole server, so I didn't have to bring the RPMs and pollute the server, because this works side by side, right? That's the nice part. Second thing, now things will get a bit harder. But we'll start slow. As I said, this Nix is nothing but a JSON. So we'll start with the Dockerfile. I'll just call it Dockerfile JSON. And I think this is, if I tell you I basically rewrote it, what we just had in the previous slide, the previous demo, into this slide, and I think most of it you can understand. Maybe the only thing is from image equals null. This means it's an image from scratch, so we don't depend on any image that we build from. Anybody? And there is contents, which is which things we want to put inside. And if we do this, do you understand what we try to do here, right? And syntax is familiar. Now let's convert this into Nix. First thing, all the columns become equals, okay? That's just how it does. Their syntax is different. All the commas become semicolons. Sadly, that's how it is. And then we have those functions that I was talking about. So first, if we go from bottom to up, packages.redis. Packages is a dictionary hash map. We call it attribute set of all those Nix packages. And then it's a familiar annotation where you select something via dot, just like any JavaScript object. So we're taking Redis from packages. The other thing, so the Docker tools build layered image, is in Nix packages, there are not only packages inside, but there are also helper functions utilities. This is one of those functions which allows you to build a Docker image, right? So saying that the Nix is only about, it's a package manager, it's a bit deceiving. That's why I like to call it a build framework a bit, right? Because you have many of those images. One of them is building, in this case, layered image. You will see why this is important. Rather than explaining it, I will show you, but in a bit. And then at the top, this is how you do, if I would have to translate this would be in a bit import, but in reality, the whole file that you see, it's a function, and these are just the arguments of a function at the top. Okay? and everything below it is being returned because it's an expression. You don't have, right? So we have arguments, which is Nix packages. And and this is, I wrote this on a file system in the docker.nix file. And yeah, how can we use this? So there are two files, which we'll just briefly look, because they are a bit more boilerplate. But it's one of those things you just need to learn. Like there is just a standard how to connect all these pieces, which kind of connects this file to the Nix command line, right? So that you can do Nix build. And there is a log file, as any package manager that you're sort of used to, creates a doc file, sort of creates reproducibility of our Docker image that we're going to build. Questions so far, before I dive and actually show you how all this works? Hope it's not too much, but I try to kind of bring it from a simple JSON to the Nix. There are a few things that that are new, right? Okay. Thank you. Please? Exactly. Now we're going to look at it. Yeah. So one of the things which you can already see now, but I'm going to show the other benefits just in a second, because you don't see the result out of this. We need to inspect the image that we just created. One thing that you can see already now is that this is a declarative way of specifying a Docker image. In the Dockerfile, you do it imperatively. You say, run this command, run this command, run this command. Now, there are ups and downs for either, being that imperative style is a bit easier to understand. And this thing is it's a bit more manageable in the long run. So instead of saying, install this, and then remove all the craft that's being that the command produced, you just say, give me Redis. Give me Redis, I don't know, any other package, Node.js, Python, Java. You say, you describe the final, what you want in a final image, and not the way how to get there. I think our tool should be smart enough to know what to do if you tell them, give me few packages, and right? Similar to Ansible, exactly. I think anybody who experienced doing things in an imperative way, and then switching to doing it in a declarative way, can appreciate, already knows the benefits. I don't know how to explain it, why this is better. You just have to suffer a bit through it, but it's worthwhile in the end. Yeah. So let's go into to really show. So explaining which terminal is which. So on the top right, because this is macOS, so I will use the Nix image to build all the Docker images. Why I can do this, because you see I didn't pass the socket, because we are using Nix to build it, so we are not using any Docker commands to build a Docker image. And I mounted the folder you see below, so bottom right terminal here. So we have this, you remember there was a simple example, and then we have this, I call it advanced, and we have all these files. On the left side, you see an editor with a Dockerfile.nix already opened. Now, I'm going to show you this boilerplate just so you're aware what's in it. But there should be another topic explaining it all. Right? So we'll open FlakeNix. There is a description. There are inputs, sort of what do we depend on. Other Nix repositories, in this case, is Nix packages and another Flake utils. And then we produce sort of outputs. One of the outputs is our packages. In this case, we use this Flake utility function to go over each system that we want to produce the outputs. These are, because we're building Docker images, these are the outputs you want. So yeah. And then we say for this, we will provide a default package, meaning that we can just avoid some boilerplate when we'll run commands. And also we pass in Nix packages for that system. You see, Nix packages, that legacy packages, is just the way to select packages for that platform. So, and then you can see we are importing a Dockerfile. So that's just a Dockerfile you see above, and that's it. So that's a boilerplate. In short, with the first time you run a Nix build command, the log file is going to be created. It's just a bunch of JSON that gets pinned for those inputs that we define, and that's it. That's what makes it reproducible. So whenever you rerun this command, you'll get the same result out of it, right? And when you want to update, there is an update function, right? When you want to update these inputs. Yes, so let's build it. So first, you remember when I tell you we need to configure our Docker image? This is what is going to tell me now, that we need to enable some experimental features. So I'm going to do that quickly. Nix command, flex, and we will append it to just the Nix configuration. And then we're going to, now the Nix command was, oh, of course, I need to move because I was at the root folder. And now the Nix command, because this is where our files are, the flake.nix. It's looking for flake.nix. And now it's going to download. One thing, when you said it's the nice thing about working with Nix, it's atomic. So if I kill it, there is no pollution on the system, meaning there is no artifacts that is like, oh, the build was halfway there. No, why I did it, because I actually want to do this, just to have a bit more, let's see, the network. Yeah. Okay, so it's building, it's downloading things that it will find and things that it, in a binary cache upstream. So probably Redis is going to be pulled down from binary cache because we took it from Nix packages. And then also all the other dependencies that Redis has. Now, let's look, while this is building, we will look at the Docker image that we built in a demo 1, because this takes, I think it takes like 2-3 minutes. So if you don't know, this is a Docker desktop. You've probably seen it. I'll just search for Redis images. So the first image is the Alpine one. The second one is the Debian one. And this is, I already pre-built it so we can move faster. It's a demo 1 Redis, so the Docker image we built from a previous Dockerfile. Sizes, right? Alpine, 44 megabytes. Redis, smaller image. It's being built on purpose on top of it, so it's already being optimized as much as you can optimize on Ubuntu. And sort of non-optimized, just like plain thing that you build from with Nix, it's 350. I'll explain exactly why. Let's look at it. What's inside? So, things that are inside, let's look, there are 83 packages inside, right? These are all the runtime dependencies. If we go to the, I think it's, yeah, this, you see these dependencies? We don't really need it, right? But because Nix works, it kind of have a default dependencies. This is also one of them. But we would actually like to get rid of it. So we'll do that in a bit. So, but you can see these are all the packages. And where they get stored is actually in the /Nix store. And then they get symlinked, right? That's why Nix can work alongside your package manager. Let's look back. So the building, okay. So just because we are working in the container, we'll copy this thing out of the container and load it. So what is produced is the exported Docker image. So Still need to load it. Of course. There we go. You will see it loads all the layers. It basically copies them. It unpacks it, and now we can use it. So let's look at this. So now going back to the list, demo2 Redis was added, same size, because we didn't really do anything, but there is one big thing that changed. Let's look. You have 94 layers. Now, for somebody that is carefully constructing and writing their Dockerfile, this looks scary, and I understand, but I didn't write those layers. I didn't have to come up with which of these layers are. You also know that we had 83 packages that we depend on, which kind of translates each package as its own layer, meaning caching is just going to be much better. Now, there are some limitations to the layers. We can discuss them, but there is an algorithm that kind of groups packages. So you cannot have more than 200 something layers. So there is a popularity algorithm that groups packages that will most likely kind of bump together. But another thing, which is nice, you see the green thing on the right side? All those packages are up to date with security patches applied, right? That's because we are using Nix packages. We're always up to date. All the patches are there. As an example, all the new bugs are there. Also true. But at least vulnerabilities that are known that usually hackers target you, you have a bit, even official Docker image from a few days has security vulnerabilities. Now, are they true or not? That's debatable, but you know, it's nice to see things being on the green side. Yes. Yeah, exactly. You can, because we can pinpoint and lock our dependencies, we just don't depend on apt-get to kind of move us in some direction, only forward. We can also move forward. We can just say, like, use this revision of Nix packages, use this package from this revision of Nix packages, use another package from this revision. You can mix match. That's the flexibility you get. I'm a bit running down on time, but I want to really show you minimal. We're going to rename this. I prepared a minimal image. So I'm just going to replace. I'm writing some Nix code. I hope you will forgive me, but this is how what I did right now. I said, don't use the upstream one. I'll provide you a custom Redis. But in my definition of that Redis, I'm saying, like, hey, use the upstream one, but disable, don't build with systemd. And just for the sake of it, so we don't have to waiting for all the tests to run, we're also going to be, disabling the tests, right? So when I do then Nix build, on the right side, it's going to pull down the build time dependencies and perform the build of Redis. I should have cached this, right? There we go. Again, if I kill this, nothing will happen. It will just be all the dependencies that were pulled down. We will not pull them down yet again. You can. That's why the atomicity of Nix is really nice. As just being an engineer developer, it can always kill a machine. Okay, we're almost there. Come on, my phone. Data plans. I hope I don't run out of data plan. Which cache? For dependencies, everything goes into the Nix store. So /nix/store. In dynamic builds, you mean? But yes, yeah. I mean, that's you would write one way is to always rebuild, the other way is to write an X expression, then you get all the caching out of it. Okay, the last bit. It's building. Yeah, it's built. How I know? It creates this result, symlink. Again, we copy it out. And Docker load. Okay, it loaded less of the things because already those layers are included from previous builds. So not right. So looking at Redis minimal. Size. It's down to 68 just by removing the systemd as a dependency. We have only 9 dependencies. So basically saying that systemd weighs about 300, a bit less than 300 megabytes. That was the reason. Removing it, right? But let's go even further, because you know, I want to have that bragging rights in the office. And let's call this really minimal. And there is a really minimal, right? So I don't want the person sitting in front of me saying that his Alpine image is smaller than mine. So Redis really minimal image. Let's just start building it. What we're doing, not seen nicely, but we do the same thing as before. We just remove the TLS support because we're going to run it locally, so we don't really need that. This thing, and then we'll do the static build, so we don't use the system gmalloc. And then some flags. Like you can alter the build of the existing package recipe. Now, I think that's cool, right? Because you can also apply certain patches that you have for Redis and still get the same thing. So it's like really fits into the workflow. Now, let's really minimal, and then let's build this. Okay, what do you think? How big is it? How much? 24. Come on, come on. Give it a guess. I buy you beer if you come close to 1 megabyte. 14? 16? 8. Okay. 3.5. Yes. It's actually a fair question, right? How do you run it? TY, this one, right? It works, right? Yes, you cannot use it through the network because my use case in that particular use case, I removed the TLS support, but for my use case, that was the saving. Now, is this something that you should do? No, right? This is my obsession. Maybe you have it as well. Maybe you will grow it. But you can see the flexibility, how you can have declarative way of describing your Docker images. That's already a good thing to have. You can have all these big amount of packages with a bit of tuning, just removing the systemd support. You can get down to similar levels as Alpine, yet having more flexibility and declarative way of defining. Plus, you don't have to think, why declarative is nice, you don't have to think about the layers to remove things when they get installed, and you get all these, all the packages, all the dependencies, runtime, are put in layers for you. You don't have to think about this, and you get a lot of caching. Please, question. Okay, so it's sort of the same as with any other Docker image. So when it's too far, you take it until either because you're obsessed and you go this way, or because, well, you don't have time, right? Or because it's already your Dockerfile. You don't want to do this maybe sometimes because your Dockerfile is good enough already. That's okay, right? But once you reach that point where you need to optimize, Nix can give you the helping hand, and you can bring the size down. Right? And is it working in production like any other image? You need to test it, right? Now, like you build an application. Now this, I'm using Redis, so most likely it's going to be tested upstream. But if you build your own application, well, make sure you have a staging, right? Or multiple staging areas. You need to test it. Don't just go straight to production, or do. You know, it's also, maybe just don't do deployments on Friday. Okay. Everything to production. So, but I also hear you, right? Most of you didn't hear about Nix until today. I would assume you think Nix is experimental. I wouldn't blame you. In my circles, Nix is production ready. Why I say? Because I've been using it more than 10 years. And I know companies using it in production. We started collecting stories, who is using it where. And it's almost like with back in the day with Clojure, because companies didn't tell you that they are using Clojure, because that was their competitive advantage. Same thing is happening with Nix, so we really have to find companies that use it. The only two I would like to expose. So this is the website. One is the IDX. Anybody heard of IDX project? You might know this company. Google, right? So IDX is from Google. Even some Googlers didn't know it, which was fun. But it's a new project. It's like developer environments, like Cloud9, but serious, tied to your Google account, all this cool stuff. That's one of them. The other one, instead of telling you, I'm just going to show you. Okay. Just going to show you, and we'll go here. Docker. Docker is using Nix. Because they are, Docker debug tools, not Docker, right? So they built this recently. This was just announced like a month, 2 ago. That you can attach and you can debug any either running Docker image or any running container. You can attach to it. As easy as, well, let's get out of this. Let me just get the name of the container. Thirsty Nordcat. Oh, man. Who is naming this? Okay. So how do we say DLD shell? So this is how I would go to the demo one Redis. You can say a Redis, or you just this. And you're inside Docker image, and you can install. I know that there is no ribgrab here, and I can install a ribgrab. You can see. Where is it? Above, it's actually pulling down from Nix packages. This is actually a domain where you can search them online. See, it's being pulled down alongside your running environment. It sort of puts it in a layer and an overlay, like work side by side. I think that's cool, especially because you can, you have some production bugs which you might use trace on it, but you don't want to ship with trace, and you don't want to do the whole redeployment. This is a really cool thing. This is just one example how you can use these Nix features and kind of bring them to your work. I think Docker Lab group engineers, they did a really cool job there. A funny part, I actually wrote searchnixos.org back like a few years back. It's funny popping up in places. Anything else? Yeah, to finish, I'm talking too long. You want to use Unix, it's a bit of an investment, as with anything else. It's a bit harder to learn than, let's say, some more popular. Nix community is aware of this. We're working on actually making the whole transition easier. Should you use Nix or Docker? I don't know. You decide. I use them both. I think I'm a better, my Docker usage is much better if I use it with Nix. And I can actually show it to many other people if I use Nix with and build Docker images. I didn't introduce myself. That's because I wanted to do it at the end, if we have time. Let's say we do. I'm an engineer at Flox. And at Flox, we try to, we're basically, our sort of marketing will hate me for this, because I just came up with this yesterday evening. But it's like we try to build, there are a lot of good features in Nix, but they are just hard to come. And you already saw the Nix you have to learn, this you have to learn. And we want to make this cycle, the software development cycle, really nice. So our motto since of yesterday for only today is easy as Docker, but powerful as Nix. If you want, I would really like to talk to everybody. What we're doing, this is open source. What we're building, we're looking for design partners, and sort of just making sure that we're building the right things, the things that people will use. Thank you. I went a bit over time. I don't think we have time for questions, but yes, no? No questions, but please, if you have, I'll gladly open. And there will be an open space regarding Nix.